Thank you for joining this lesson. I appreciate everyone for turning up. I can see you are ready for the lesson. We are directly going to the paper, Mathematics Paper 2, as we had scheduled. Remember to invite a friend to today's lesson. Please remember to bring a friend on board. We'll be discussing a very serious paper, and you people should take it serious. Remember today, after inviting a friend, we are saying hi to our principals. So greet your principal as we continue learning. Tell us your school, where you come from, and your principal. So this is the paper that we are going to discuss. Remember, our number is on the screen here, as you can see, 0704 1533 66. That is the number you can use to consult. That is the number you can use to request for revision materials. It is also the same number that you can use to appreciate the good work that you are doing here. Number one, directly, it's a question on errors and approximations from 3 topic 2. The expression 1 plus x over 2 is taken as an approximation for the square root of 1 plus x. Find the percentage error in doing so if x equals to 0.44. Give answer correct to decimal places. So the accuracy of 2 decimal places should only be applied to the final answer. This one is not restricted to the workings that you shall do. So the exact value is supposed to be the square root of 1 plus x, which will give a value equal to 1 plus 0.44. Then we carry out square root. Now the exact value is going to be the square root of 1.44. Remember, the square root of 1.44 is 1.2. The square root of 1.44 is 1.2. The positive square root, of course, because we are dealing with a quantity here, because errors are taken on measurements. And now with measurements, you cannot start saying that the square root is either positive or negative. Even if it is true, we stick to the positive square root of the value. After that, now, remember that is now the exact value, but we have an expression here which is taken to be the approximation for this one. So this is actual. This is the actual value. What about estimation? Somebody estimated it as 1 plus x out of 2. This will be 1 plus the value of x, 0.44, divided by 2. This shall be, we take 0.44 over 2, then we add 1. This will be 1.22. 1.22. This one now is the approximation. This is the approximation, or the approximated value. For us to get percentage error, we are supposed to get the error first. So percentage error is given by the error out of the actual value times 100. It's good for you to know that when we talk about error, we mean the difference between actual value and the approximated value. Approximated value can also be called estimated value. So we can take 1.22, we subtract 1.2. When we are finding the error, any can subtract the other because we just want the difference. An approximation can be slightly above the actual or slightly below the actual. So the bigger one, or we subtract the smaller one from the bigger one, depending on the estimation. The error we shall get here should be divided by actual value, 1.2. Then whatever we are getting now, we multiply by 100. So allow me to say that 1.22 minus 1.2 is 0.02. Then we divide by actual 1.2. And after this, we multiply by 100. When I multiply by 100, I'm getting 1.666 recurring percentage. 1.66, but we have been told to 2 decimal places. So 1.67%. That is the error. That is the percentage error. Percentage error. Remember to subscribe to our platform. Remember to share our link with your friends. Remember to tell us where you come from. I should say hi to a few individuals. Thank you so much for turning up. I can see you are really doing a great job. Migwani Boys High School, Ngoto Boys. This is wonderful. Mwani girls. This is great. This is great. Identify yourself kindly. Identify yourself. You can say hi to your chief principal. Say hi to your principal. Yeah. Wami girls. Wow, wow. This is great. Kadhiani girls, the Kitondo School. Wonderful. Wonderful, wonderful, wonderful. Mangu High School. This is great. This is great. Meanza mapema. Yeah, it should be so. Jaden, we must start early. Otherwise, continue following. Nick Mutua from Kitondo School. Wonderful. All right. So we can continue. Let's go to number 2. Number 2, we have a question here. It says, express the following in SAD form and simplify by rationalizing the denominator. To express some, you can see they are trigonometric ratios, and we want to express them as SADs or in SAD form. Let me show you how to go about this. For the 6, this is how you should proceed. Get used to drawing a certain equilateral triangle. Let's say it has 2 units. Equilateral means all the sides are equal. We have 60, 60, 60, then 2 centimeters or 2 units, 2 units, 2 units. Then this, now you divide it into 2. When you divide into 2, exactly into 2, you will get 1 unit at this point and 1 unit at this point. And the height now here is going to be, the vertical height shall be 2 squared minus 1 squared. Then we take the square root. So when we are taking a 4 minus 1 should be 3. So the square root of 3 is now the height. We leave it as a SAD instead of writing 1 point anything. We just write it as the root of 3. Now, you should know that when you divide it into 2, this angle here became 30. But the one here remained 60 degrees. And so, the cosine of 60 now, as you can see in the question, the cosine of 60. Cosine is usually given by adjacent length divided by the hypotenuse. The adjacent length divided by hypotenuse. So adjacent length to 60 is just 1. The hypotenuse is 2. Therefore, the cosine of 60 is half. And even when you prove with your calculator, cosine of 60, you discover that it is half. Then we have a 45 now. So for 45, you can use an equilateral, not equilateral, but a right angled triangle, which is also isosceles, such that being isosceles, it has 2 equal sides and 2 equal angles, but one of the angles is right angled. Therefore, this is going to be right angled. We have 1 unit here, but it's equal to this other one, which is also 1 unit. So the angles at this point will be 45 each. This is 45. Yeah. So we can get the hypotenuse, whereby we need 1 squared plus 1 squared, the square root. So we will find ourselves doing now the square root of 2. And when the hypotenuse becomes the square root of 2, now we can say the sine of 45, sine 45 can be given by adjacent length of 1, okay, opposite length of 1, out of the hypotenuse of square root of half. So this is now sine 45 in third form. Sine 45 in third form. So we shall say that now we want 1 divided by, we now rewrite our expression up there, divided by sine 60, or cosine of 60, sorry, half minus 1 out of the square root of half. And when you have written this way, to proceed in the solution now, you need to multiply the denominator with the conjugate and also the numerator with the conjugate of the denominator. The conjugate will be half. Now that the third here is having a minus with a plus now. Yeah. Then we also multiply the numerator by the same half plus 1 out of the root of 2. 1 out of the root of 2. Now we can simplify. We can now simplify, whereby in the numerator we shall have half plus 1 out of the square root of 2. This one should be divided by, when you consider the denominator or other, any third multiplied by its conjugate, it's usually a simplified difference of 2 squares. With a simplified difference of 2 squares, we need to take the first term squared minus the other one squared. We just expand a difference of 2 squares. So half squared shall be a quarter, then minus 1 out of 2 squared now becomes half. 1 over 2, 1 over root 2, then you square. We shall get half. We shall get half. Therefore, a quarter minus half in a fraction form, a quarter minus half, we get negative a quarter. Negative a quarter. So now we can talk about 1 over 2 plus 1 out of the root of 2 divided by negative a quarter. And now with negative a quarter, we can multiply all through by 4. When we multiply all through by 4, we're not going to have any third now. Or rather, we can say that to do away with the denominator, which is a fraction, you know, this numerator is being divided by negative a quarter. So dividing by negative a quarter means multiplying by 4, which will be negative. Multiplying by negative 4. So the numerator multiplied by negative 4 will be half by negative 4, giving us negative 2. And now, when you multiply by negative 4, it should be minus 4 out of, yeah. So this one is now, though it's good not to remain with a third in the denominator, it's not good to remain with a third in the denominator. Sorry, I can see some interruptions here. Thank you so much for this continued support. Yeah, Principal Wangapala, wow. Stacy from Muruguru, girls. Cheruyot. Kiliboni boys. This is wonderful. Jonathan Mugo, Kitondo School. This is wonderful. This is great. Continue saying hi to your chief principal. Continue greeting your principal. Wow, this is wonderful. I can see Chondoni girls, Kitui County. That is great. Hello to our chief principal, Mr. Mokaya. That is great. You should have told us your school. But this is wonderful. This is wonderful. Let's continue learning together. Mathematics paper 2 is among the easiest papers. So to finish up, we are saying that we can again now multiply. We can simplify this part of the answer, -2, then minus. Instead of having this part, you multiply both parts by √2 and also √2 here. When you are starting the simplification of surds, there is that part before you go to the concept of conjugate. Whenever it's a simple fraction but having a surd, this is how you simplify. You multiply by the surd, both on the numerator and also on the denominator, so that it becomes 4√2 divided by, when you multiply √2 by √2, we get 2. And that means now there can be a simplification, -2 minus 2 the root of 2. Minus 2 the root of 2. So now this can be further simplified by saying 2 is common, so we can remain with, or -2 is common anyway. Yeah, -2 is common. So -2 factored out, we shall remain with 1 and a positive root of 2. So that is the simplest form for the above surd. The simplest form for the above surd. Remember, our consultation line is on the screen. This is the number that you can use to consult. Through the same number, you can appreciate the good work happening in this platform. Make Q the subject of the formulae. Make Q the subject of the formulae. Remember, there is P equals to cube root of NQ minus M divided by Q. So we can start by cubing both sides. Cubing both sides. So when you cube both sides, P shall become cubed. This is equal to, when you cube both sides, now the cube root sign disappears, and you shall have NQ minus M divided by Q. Divided by Q. And now you can cross multiply. Once you cross multiply, you discover that we have P power 3 Q. This is equivalent to NQ minus M. Yeah, that's now a linear equation. Allow me work with these numbers such that we avoid a lot of negatives, such that if M comes to this side, it will become positive. And now we have NQ. We subtract P power 3 Q. We are taking negative M to be positive, and this term here to become negative. Now with this, we can say M equals 2. We factor out Q, then we remain with N minus P power 3, like that, when we factor out Q. So to remain with Q alone, we divide through by the coefficient of Q, which is N minus P power 3. So this is now the right formula, with Q being the subject. There is a time we were doing a paper 2. There are those who are following, and I would request that wow, Emmanuel Springs girls, say hi to Mr. Dixon Mangela. Mr. Dixon Mangela is a great friend, a schoolmate, a campus friend, and a brother. Thank you so much. I will say hi to your principal. Hello to Mr. Benson Mano. That is the chief principal, Machaco School. I will send you a regards. Thank you so much for following. Thank you so much for following, for being around. You can see Kitondo boys, Kitondo School is around. They are so consistent. Mr. Peter, your math teacher and your physics teacher also, is a great friend of mine. This is wonderful. This is wonderful. Okay, there's a time we were doing a different paper 2, and I would like to post the question which was there on the subject of formulae. We never concluded well when we were solving this question. Those who are alive know. Make x the subject of formula. Remember, on the right hand side there is a root sign. So when we start squaring both sides, we square to eliminate the root sign, such that the right hand side now becomes bx plus x squared. Then now the left hand side, you should square with certain order, such that you don't just mess up. So we are squaring everything on the left hand side, such that we get a squared. Then the sign which follows here is a minus. We multiply everything by 2. So 2ax, then plus x squared. That is how we expand according to quadratic identities. Mathematics Form 2. You should do a review of your Form 2 work. Plus now x squared on this side. With this now, we can group like terms such that x squared and x squared will cancel out. This x squared and this x squared cancels out because it's appearing on both sides and they are positive in both cases. Remember, we are making x the subject of the formula, so we can remain with a squared equals to, we are having bx. Then now we add, when we take 2ax to this side, it becomes positive. And now we can factor out x such that we remain with b plus 2a. Remember, at this point, we are still having our a squared. So to remain with x, we divide a squared by, b plus 2a. b plus 2a. So that is how we were supposed to make the subject of the formula in such a case. We are continuing. I'm still receiving greetings for your great principles. Greetings for your lovely principles. This is great. Madam Damaris Munyao, Kadiani Girls, wonderful. Mr. Enos Wasike, Kakamega School, wonderful. The Kitondo School, Richie. Chief Principal Kitondo, Sironga Girls. This is great. This is great. This is great. Say hi to Mr. Mosao. That is 4B Machakos. This is great. This is great. Jonjo Girls, Madam Winnie, wonderful. I send greetings to your teachers. Mosingo School, Mr. Mokaya, the Chief Kitondo School. This is great. I think Kitondo are doing a good turn up. Bahati Girls represented. Mr. Magiri, Ngoto Boys. That is wonderful. I send greetings to Mr. Magiri Douglas, the principal Ngoto Boys. Charles 4B. That is great. St. Angelas. So that is great. We continue with our paper now. The paper for today. We continue. We are on statistics number 4. The data below shows the age of 10 pupils picked at random in a primary school: 6, 11, 13, 10, 13, 14, 8, 7, 12, 20, P, and 9. If the summation of f of x squared, the summation of f of x squared equals to 1360, determine the value of P, and hence find the standard deviation. Find the standard deviation to 3 decimal places. 3 decimal places. This is a statistics 2. We are supposed to work out a standard deviation, and that is after determining the values of f of x squared. So we need to square each value here. Summation of f of x squared. We just square each value. Then we add. And we are supposed to get 1360. We're supposed to get 1360. So when we get 6 squared, we add 11 squared. We add 13 squared. Remember, x are the values here because they are not classes, so that you may say x is a midpoint. The frequency for each value is just 1. So I'm treating each value independently. So 6, 11, 13, 14, 8, 7, 12, 20. We also square. P should also be squared, and 9 should also be squared. They are all supposed to give us 1360. So let me square all these values. 6 squared plus 11 squared plus 13 squared plus 14 squared plus 8 squared plus 7 squared plus 12 squared. We also add 20 squared. We add 9 squared. I'm getting 1260. So to remain with p squared, I should take 1360 and I subtract 1260. I'm getting exactly 100. Wow. So to get the value of p, now I'm having the square root of 100, which is not anything else but 10. So we have the value of p as 10. The value of p as 10. This is wonderful. Madam Kamweti from 4 West. This is wonderful. This is wonderful. I mean, Mr. Kiminza McBee. This is great. This is great. All right. You are so active today, and this is wonderful. I want to request people to kindly subscribe. Please make sure you subscribe to this platform. Make sure you share the link. Invite a friend kindly. Somebody introduced you to shifting grades. Introduce a friend so that they may also learn. We have our value of p, and now we can proceed to determine the variance, standard deviation that is, and we have been told to 3 decimal places. Remember, for us to get variance, we have to get the mean first. Let's get the mean of each value. For us to get the mean, we should add all the values now, starting with the 10 itself, the value that we have just calculated now, then 6, then 11, then 13, plus 14, plus 8, plus 7, then plus 12. After 12, we add 20. After 20, we add 9. We have already added p. I'm getting 111. Then I divide by 10. 111, 110 over 10. So I get 11. So 11 is now the age. If 11 is the age, we can get deviations of all the values from the mean. Deviations of all the values from the mean. Then we square the deviations and we find the mean of squared deviations, which will be our variance. After that variance, now we can calculate what we call standard deviation. So for us to get deviations, we need to get each value and how it's deviating from the mean. Each value minus the mean. Each value minus the mean. Each value minus the mean. So we need to take the first value, 6 minus 11, we get negative 5. Then we go to 11 minus 11, we get 0. We have 13 minus 11, we get 2. We have a 14 minus 11, we get 3. 8 minus 11, negative 3. We go to 7 minus 11, negative 4. Then 12 minus 11, positive 1. There is after 12, 20 minus 11, we get 9. P is 10 minus 11, negative 1. And finally, there is a 9 minus 11, negative 2. So now, to do away with the negative signs on the values of the deviations, we now square the deviations. So deviations squared. Negative 5 squared, 25. 0 squared remains a 0. 2 squared, 4. This is a 9, and this one also 9. Then 16, 1. 9 squared, we get 81. Sorry, 81. Then this will become 1. This will become 4. So we have all the deviations squared. We can get now the summation of deviations squared. Sum of all deviations squared. So we add deviations squared, then we divide by the number of items for us to get what we call variance. So variance in this case will be given by, we add all the deviations squared, 25, 0, 4, 9, 9. We also add 16. We also add 1. We add 81. We add 1, and finally 4. I'm getting 150. So 150 divided by 10 items. I'm getting a variance of 15. For me to get standard deviation, I should get the square root of variance, because variance is s squared. So s will be the square root of 15, and I must adhere to the accuracy of 3 decimal places. So the square root of 15 shall be 3.873, because it's 29. So we make this one a 3. So this one to 3 decimal places is going to be our standard deviation. Standard deviation. I believe you are followed. I believe you can redo the question given a similar chance alone. Given a similar chance, you can still do the question. Thank you so much. I can see you are still around. Please remember to Mr. Murphy, McB, Madam Doma, McB. This is great. This is a good turn up. That is a Machako School. Wonderful. Representing Iko Boys National School. Doing great, teacher. Thank you so much. I will continue doing my best. This is wonderful, sir. Keep teach. Math teacher, Baringo School. That is wonderful. That is really wonderful. Stanley Kitondo School. Wow, this is wonderful. We shall continue doing our best. Let me have everyone subscribing to this platform. Please subscribe. Remember to share. Remember to share. Mr. Kevindu for H. Kiongwani Girls well represented. This is wonderful. Mr. Patrick, math teacher for E. Ngoto Boys. I send greetings to Mr. Manyala Patrick Ngoto Boys. Thank you so much. Mrs. Mosioki, St. Angela's. That is wonderful. Wampoi Mwanki, Principal Naivasha Girls. Great. That is great. That is great. That is great. All right. We check the next question now. It looks like a question from variations. Okay. Let's look at it. Let's look at number 5. Let's look at number 5. The volume V of a cylinder varies jointly as its height and the square of its radius. Calculate the percentage increase in its volume when radius increases by 5% and the height h increases by 10%. Let's first of all write the first equation showing the relationship between the volume, the height of a cylinder, and also the square of the radius of the cylinder. So volume varies directly as the height and also as the square of the radius. So r squared. That is how they vary. Okay, we can introduce a constant and say V equals to a constant multiplied by h times r squared. This is the general equation connecting the three variables. Now, this is original v. And now we are told that there is a certain change here, whereby we need to calculate percentage increase in the volume when radius increases by 5%. So the new radius shall become 105% of the original R. So 1.05 original R. What about the new H? The new H becomes, it increases by 100 and it increases by 10. So it becomes 110% of the original H. So this will be 1.1 H. With this now, we can calculate the new volume then, or determine constant multiplied by H. The new H is 1.1 original H multiplied by R squared, 1.05 R, and we square because new R is 1.05 R squared. So now we can carry out the multiplication and know the exact valuation of V in the new case now. So we shall say that V, the new V, equals to, we take 1.1, we multiply by 1.05 squared. This shall be 1.12, we have a 21275 K H R squared. So this is the new V. For us to get percentage change in V, we need the new V minus the original V, new V minus original V, then we divide by original V, and we have to multiply by 100 because we are getting percentage change. So the new V is 1.21275 K H R squared minus original, which is K H R squared, divided by the original K H R squared. Looking at this, we can factor out all these variables and we cancel them. They cancel one another because K H R squared, we can remain in brackets with 1.21275 minus 1. Then we are dividing by K H R squared. So this now can cancel out one another. And remember, we have to multiply by 100. So we'll be taking this minus 1 multiplied by 100, giving us 21.275. 21.275%. This is percentage increase. The percentage increase. We have not been restricted to the accuracy to stick to. Our number is still here. You can appreciate the work happening here using this number. Remember to subscribe to this channel. Remember to share the link with friends. I can see you are still holding on. Brian, the Kitondo School, this is great. Best platform to learn mathematics. Thank you, Mwalimu. Leo umenisaidia kuelewa commercial arithmetic too. Wonderful. Continue following. Remember, apart from the live lessons, this channel is having more than 1,000 other videos which have been recorded for you in mathematics and physics. Kindly follow up with what is happening in this channel. Remember to introduce a friend to the platform. Remember to subscribe to this channel. Remember to share the link with a friend. Invite someone to the live broadcast. Let us learn together. Introduce your friend kindly. Introduce somebody the way I'm doing, the way I am introducing friends, the way I forwarded the link to your teachers and they now invited you. you take up the responsibility of introducing a friend. Please remember to introduce a friend. We are continuing. We look at number 6, which is a question on number 6 is on intersecting codes. Yeah, on intersecting codes. Code AB and CD in the figure below intersect externally at Q, just as you can see. Somebody tells us that AB equals to 5, BQ equals to 6, then DQ equals to 4. Calculate the length of code CD. Calculate the length of code CD. For us to calculate the unknown length, we're supposed to know that when codes are intersecting externally, there is how the proportions of the total code are supposed to relate. For instance, because the codes have been labeled, allow me use the labeling in this diagram to give you a summary of what you should do when codes are intersecting externally. You should take the total code from A to Q. So A to Q, we multiply by the outer portion, BQ. Now, this one is giving us the same as when we take the other total length, and that is a CQ, this one multiplied by the outer proportion of that, that is a DQ. Yeah, this is it. If we let the unknown length here to be X, then we will tell ourselves that when we take AQ, that is a total of 11, 5 and 6, a total of 11. Then we multiply by the outer portion, 6. This will be the same as CQ, that is 4 plus X. Then this one should be multiplied by the outer portion, which is 4. The outer portion, which is 4. So now we can open brackets or solve otherwise. 66 equals to 16. 16 plus 4x. So we can remain with 4x at this point, and we subtract 16 from the other side where we get 50. Yeah, then now we can remain with x by dividing 50 by 4. Is it 12.5? 50 over 4, yeah, 12.5 centimeters. 12.5. These are centimeters. These are centimeters. So that is it. We can check number 7, which is on rates of work and proportions. Rates of work and proportions. You better be serious in this one. You better be very careful with this question. Rates of work is a simple concept, but most of the students tend to think that it is a difficult concept. Yet it is very cheap, easy to understand. I can see people who are following recorded videos. They don't know that we are live revising mathematics paper 2. I continue recognizing you people. Thank you for tagging your great principal, Edwin from Nyamagua Boys. El Sal from Nep Girls High School. Baringo High School represented. We have Kalebia Mukute for East. Chief Principal, Kitondo School, Garissa High School, Mangu High School, and I'm so happy for doing this wonderful work. Thank you so much. From Moi Girls Eldoret, Mesh Mumo from Movuti Boys, wonderful. Mr. Mokaya is really being recognized. I recognize Tumaini International Girls, wonderful. Representing Makweni School. This is great. Continue following Makweni School. Continue following Machako School. Continue following Kitondo School, Ngoto Boys. We have Tumaini International and everybody else who is around Garissa High, Moi Girls Eldoret. Everybody feel recognized. Continue inviting friends, regardless of the school that they come from. Just invite them. Lugulu girls, I recognize you. Caroline Mino, I say hi to him. This is great. Igose Boys. Maweni. This is great. This is great. I cannot manage to read everybody's comment, but at least I will ensure that I recognize Ndalani Secondary. This is great. Okay. Rates of work and proportions. Jen can do a piece of work or a piece of job in 4 days, while Mary can do the same piece of work in 7 days. We are told that Mary and Jane did the job together for 2 days before Jane fell sick. Mary was left to complete the job. How long did it take to do the job? How long did it take to do the job? Let's work out this. Jen alone takes 4 days. So if we start working with Jen, then we will say that for the case of Jen, if she takes 4 days to do the work, then it means in a day, Jen works a quarter of the job. A quarter in a day. A quarter of the job is what Jen does, so that she requires 4 days to do it completely. Then if Mary takes 7 days alone, it means in a day she works a seventh. In a day, she works a seventh of the total work, so that if she's working a seventh of the work, then when she works for 7 consecutive days, she will finish the work. Jen working 4 days, she need 4 days. So she works a quarter, and that's why she requires 4 days. Now, each day, Jen works a quarter. Each day, Mary works a seventh. That means when they are combined now, when both of them are working, we take a quarter and a seventh, and we shall say that a quarter and a seventh is giving us 11/28. So 11/28 is what they do in a day while combined. In one day, while they are combined, they work 11 out of 28 of the work in one day. If that is what they work, and the instructions are telling us that now Mary and Jane did the job together for 2 days. What about for the 2 days that they worked together? For the 2 days before Jane fell sick, for the 2 days, they are going to work 2 days multiplied by the proportion done in one day. This is going to be 11 out of 14. So within 2 days, before the Jane fell sick, they had worked. When we multiply this by 2, they had worked exactly 11/14 of the work. 11/14 of the work. So there is a remaining proportion now. After the working for 2 days, there is remaining proportion, which means now it is 1 minus what has been worked. And this is going to be 3 out of 14. So 3/14 of the work is what has remained undone. If this has remained undone, and we know the rate of work of Mary, who is now going to work alone, we will say that, for Jen, remember, Mary was left, sorry. So Jen falls sick and Mary was left. So it is Mary now working alone. So we will say 1/7 of the work is done in one day. What about 3 out of 14 of the work, the remaining fraction? So 3/14 by 1 divided by a seventh, which means times 7/1. Divided by a seventh means times 7/1. So by 7 we can have 1, and by 7 we can have 2, and this shall be 1.5 or 1.5 days. So she's going to do the work for 1.5 days, but you are supposed to know that we are told to find how long did it take to do the job. So the doing of the job took, we have 2 days initially, Then now Mary working alone takes 1.5 more days. This is 3.5 days. 3.5 days. If, yeah, the total work is 3.5 days. Alternatively, there is another setting which could have asked, how long did it take Mary to finish the remaining work? But this is different now. Apart from taking 1.5 days to finish the remaining work, the question is about how long it took to finish the job. There were 2 days in which the girls had worked together. I can see you are increasingly coming in. Say hi to Ngoma Boniface. Good work, teacher. Thank you so much. I can see a colleague teacher there. KCSE Math Tutorials. That is a good platform for mathematics tutorials. You can also follow and see what is happening there. Dennis Mwita, Ratanga boys. Wonderful. From Kitondo School. The mighty Simisi, well represented. Wonderful. Good work. Students, let's follow to the end. Thank you so much, my colleague, Mr. Peter from Kitondo School. I can see your boys are really turning up, and this is encouraging. Mangu High School class 2024. That is great. Mangu School, continue following, invite friends, as Kitondo School is doing. Kitondo is doing a great job. I can see boys tagging their chief principal, and now I see their wonderful teacher, Mr. Peter, who is a friend of mine, still following. So this is great. This is a great encouragement. Yeah, I can see guys are saying hi to their teacher. Good work, my friend. Thank you so much. Thank you so much, Onyuma. Now we can check number 8. Number 8. Remember to subscribe, gentlemen. Remember to subscribe. Remember to subscribe to this platform. Remember to subscribe. Remember to invite friends who are also going to subscribe. The sketch below represents the graph of y equals to x squared minus x minus 6. Find the area bounded by the curve, the x-axis, the y-axis, and the line x equals to 5. Our number is there, just above the curve. We can see the curve. The purposes of sketching the curve is to show us how the area behaves. If the area is on the same side of the x-axis, we just integrate once. Remember, we have not been told to estimate area. We have been told to find area. That means we are going to do area by integration. All right, we are going to integrate partially or twice. First of all, we integrate from 0 to 3, then from 3 to 5. These are two different areas lying on two different regions. And so we shall calculate independently. So the curve being integrated is the one up here. So we are integrating from 0 to 3 first, depending on how the curve is. The area is divided into 2. We have from 0 to 3, then from 3 to 5. So 0 to 3, the curve x squared minus x minus 6 with respect to x, of course. Then after this, we shall add the area from 3 to 5, the same function. The same function with respect to x. Let's continue now. We shall have, when you integrate the first term, the power increases to power 3, and we divide here such that we get a third x power 3. Then minus, the power again increases to power 2, and the new power divides such that we have half x squared. Then minus 6 is having x power 0. So x power 1 now is introduced. And when 1 divides, 6 will remain the way it is. The other one will be a constant, and it will definitely disappear because of the subtraction. Remember, this is a definite integral from 0 to 3. Actually, we can finish up with the first area. We underline it. So we substitute 3. so that we have a third 3 power 3 minus half. Then we have 3 squared. We subtract 6, 3. This is going to be okay. We subtract when 0 has been substituted. And when you substitute 0, because every term is having x, it will definitely become a 0. So now we can substitute a third into 3 power 3 minus half into 3 squared minus 6 into 3. This is giving me exactly negative 13.5. Negative 13.5. The negative in this case means that the area is below the x-axis. Just a negative to show location of the area. But now the amount, the area itself now, the magnitude is just 13.5 square units. Square units. So we now forgo the sign and we adopt the size of the area. The negative is just to show where the area is located below the x-axis. Now we are taking the same function because because we are having the function already integrated. Now we are going to fix from 3 to 5. So a third x power 3 minus half x squared minus 6x from 3 to 5. So from 3 to 5, we start by substituting 5. So we will have a third 5 power 3 minus a third 5 squared minus 6 into 5. Then we will be subtracting when 3 is substituted. And when we substitute 3, we shall get negative 13.5. When 3 is substituted, we get negative 13.5. When 3 is substituted, the value is already up here. The value is already up there. We already did that. And we know what we get in case we substitute 3. Thank you for staying around. Menengai, hi. Good work, sir. Thank you. Thank you so much. John Masesi, look, Kenya boys. Great work, Mwalimu. Can you base on differentiation and integration? I don't know what you mean. Okay. Njoro girls, good work, Mwalimu. Anesta, Elijah from Githinji High, Nyandarua. That's great. Okay. What I want to assume you mean is that I revise topic-wise, and that's a good idea. So we shall check that. I will check on that personally. I will check on that personally. Okay, thank you. Now we can finish up a third. A third, then we will have a 5 cubed minus again. Remember, this is half. Sorry. There is a, yeah, this is supposed to be half. So we need to have a half. Then 5 squared minus 6 into 5. This is giving me negative 5 over 6. So we will have negative 5 out of 6 minus negative. So it becomes positive. Minus negative 13, it becomes positive. So I add 13.5. This becomes 12 and 2/3. 12 and 2/3 square units. So total area is going to be 12 and 2/3. Then we add 13.5. When I add 13.5, I'm exactly getting 26 and 1/6. 26 and 1 out of 6 square units. This will be the area now. This is the exact area bounded by the curve, the y-axis, the x-axis, and the line x equals to 5. We continue with number 9. Use matrix method to determine the coordinates of the point of intersection of the two curves or the two lines. There is a line here where the equation has been given, and also another line where the equation has been given, and we are told to use the matrix method to determine the coordinates of the point of intersection. In other words, we are solving the two equations simultaneously, but we have been restricted to the method of matrices. Restricted to the method of matrices. Kitondo School, wonderful. From Garissa High, great. Maweni, wonderful. Well understood. Thank you so much, Teacher Oduor. Wonderful, wonderful. Happy Moment High School. That is great. State House Girls, asante sana. Wonderful. Please invite your great friends. We are supposed to be, before you open schools, people should be turning up when they are almost 1,000 for one lesson. So please start introducing friends. Start introducing friends to this platform. It's going to turn their lives around. It's going to transform their mathematics life. Please don't be changed alone. Catherine Kisau Girls. Thank you. All right, use matrix method. For us to use matrix method, we are supposed to ensure that the terms are aligning in the two equations. For example, if 3x minus 2y is equal to 13, then on this other side, we should start with x. So we rearrange the variables in equation 1 to start with x plus 2y, then equals to, instead of 0, we will have -1 going to that side. Now we are having our linear equations well arranged. What we go to is the matrix equation now. Matrix equation, we write 3, then -2, 1, then 2. This one is called the coefficients matrix. Then we go to the variables matrix, xy. This is equal to 13, -1. This is called the constant matrix. So we have constant matrix. Let me name them, though it's not necessary. Constant matrix. It's good to know, but nobody will require you to identify them. This is called the variables matrix. The variables matrix. Then we have what you call the coefficients. The coefficients matrix. Now, the next thing that every student should know is that after this, we are supposed to work what we call the inverse of the coefficients matrix. So the inverse of the coefficients matrix can now be calculated very efficiently by first of all getting the determinant, the date. The date is going to be 2 by 3. That is the product of the elements in the leading diagonal minus the product of the elements in the other diagonal. So 6 minus -2, and that is going to be +8. So we have 8 as the determinant. Now we are supposed to get the inverse of the matrix, whereby we need to we divide by the determinant every term, but there is something we usually do for us to get the inverse. We interchange the positions of the elements in the leading diagonal. The leading diagonal is also called the principal diagonal, which is also called the main diagonal. So you change the positions for the elements in the main diagonal, such that 2 takes up this position and 3 goes down here. Then now for the other elements, we just change the sign. If this is a 2, now it becomes, if it was a -2, now it becomes 2. This is a +1, now it becomes -1. Imagine we are through with identifying the inverse of the matrix. What happens after this is a pre-multiplication. We pre-multiply the matrix equation with the inverse of the coefficients matrix. Let me show you how we arrange that. We start with 1 of 8. It's what we call pre-multiplication. We multiply with the matrix itself. We are multiplying both sides. XY equals to, we also start with the same here. A eighth, 2, 2, negative 1, 3. Sorry. On the right hand side, we are having different things. On the right hand side, we are having 2, 2, negative 1, 3. We start with the matrix, yeah? Then we multiply with the constants matrix, which is already there, 13, 1, negative 1. That is how the matrix are supposed to be organized. That order will earn you a good mark. Please ensure that you present your mark that way. Why we change the values in the main diagonal? Remember, we are calculating inverse, which is almost the same as what we call the reciprocal. The reciprocal in numerical cases, because a matrix times its own inverse gives us 1. It's like we are getting the reciprocal of the matrix. It's like we are obtaining the reciprocal of the matrix, so we have to interchange a few things. So now we don't even carry out the multiplication on the left-hand side. Reason being, everybody should know that a matrix times its own inverse should give us the identity matrix. The identity matrix is a matrix whereby we have 1, 0, and 0, 1. A matrix which is having 1 in the main diagonal and zeros elsewhere. Therefore, a matrix times its own inverse should give us the identity matrix. And so there is no need to carry out the multiplication, because this is exactly what you shall get even when you multiply. Let's now see multiplication on the right-hand side. Multiplication of a matrix should be row times column. So the row times the column, 2 by 13 plus 2 by negative 1. 2 by 13 plus 2 by negative 1. This is giving us exactly 24. In the second case, you shall start with, remember there is a 1 over 8 which is not affected, still outside the bracket. Again, the other row here times the same column. So we will have negative 1 into 13, then plus 3 into negative 1. This is going to give us negative 16. Negative 16. So we should again know on the left-hand side, a matrix multiplied by the identity matrix remains the way it is. You cannot change a matrix by multiplying it with the identity matrix. So XY has to remain as a matrix because it has been multiplied by the identity matrix. It remains as it is. This is equal to, now 1 over 8 can multiply this matrix, whereby we get 3 and negative 2. If x y equals to 3, 2, then we can resolve that x equals to 3 and y equals to negative 2, and get back to our question, which says, using the matrix method, determine the coordinates of the point of intersection. So a point of intersection should be presented as a coordinate. You present it as a coordinate, you don't leave it at that point. This is what will earn you the last mark, when you present it as a point, or rather a coordinate. Our number remains to be around. This number, you can make good use of this number by refreshing the teacher who is giving some good content to you during the holiday. Remember to use this number. You can appreciate our work using that number. There is another equation here, number 4. Another question. The figure below shows an arc. The figure below shows an arc of a circle. through 3 points, A, B, and C. Let's look at the question very well. Calculate the coordinates of the center of the circle. There is a known center now for this circle. We are just given a portion of the circle, and we are expected to find the center. I hope you are still around and following. Mark B to Kondani. Wonderful. Thank you so much, Mark B. Continue following. Garissa High School, I recognize your presence. Kitondo School, Kikelenso Secondary School, Mrs. Doris Mutua. Thank you so much, Kikelenso Secondary School. I recognize you. Mumbuni School, Dan from Mumbuni School. Thank you so much. Thank you, thank you, thank you. Let's continue now. Calculate the coordinates of the center of the circle. Remember the circle as an unknown center. We can just make it, let's assume that this is the circle. Then we can let the center to be somewhere here. Allow me give some coordinates to the center. I'm calling them XY. Now with the center XY, I'm going to use an approach here. I know there can be several opinions on how to solve this question. When we look at the distance, as long as point A is on the circumference of the circle, then the distance from A to the center is also the same as the distance from B to the center. It's also the same as the distance from C to the center. All those distances are equal. And now that there are coordinates provided, we can apply the vector approach, whereby I will say from A to the center, assuming the center is center O, from A to the center, or distance AO, from A to the center, let me show you. From A to the center, that's going to be X minus 2, because the X coordinate of A is 2. When we square this and we add again the dimension in the Y component, which is going to be Y minus 5, and we also square this, we will be able to get the distance. That is the magnitude of a vector. Again, the distance from B to O, B to the center, it means we can get X minus 3. We square this, then we add Y minus 8. And we also square, we will get the same distance. Now it means if this is so, and we are saying the two distances are the same, then the distance from A to O and also from AO, the vector magnitude, is also the same as BO, the vector magnitude. So we can now start equating a few things here and say we can expand actually before equating. We can expand X minus 2 squared, it will be X squared, the negative 4X plus 4. That is the first bracket expanded. Then plus the second one, we have Y squared minus, this will be 10Y, because 2 times Y times 5, we add 25 when we square 5. This one is the same as, we also square the other side, we expand now. When we expand the other side, we have X minus 3 squared. It shall become X squared minus, that should be 6X, then plus 9. Then we add Y minus 8 squared, so Y squared minus 2 times Y times 8, it should be 16Y. Then we add 64. Those two are equal. When we start grouping like terms together, X will cancel with X squared. This one will cancel with this. Then Y squared also with Y squared, because when you bring them together, they will cancel one another. But now we can start grouping. We can start grouping now. And from this, we can say that, I can start by grouping the x's. And I'll say negative 4 plus 6, because negative 6 taken to the left-hand side shall be positive. Negative 4 plus 6, it becomes 2x. Then for y, I start with a negative 10y plus 16. It becomes positive 6. Y is equal to, I'll be having 64 plus 9. Then I subtract 4 plus 25. I subtract 4 and 25, and I'm getting exactly 44. So this is one equation. I can come up with another equation by also getting the vector from C to the center. So from C to the center, that is a vector CO or OC. I need to get x. I subtract 4, then I square, and I add y minus 10. I also square. I can expand actually this one. When I expand this one, I'm getting a x squared minus 8x plus 16. Then I add, this shall be y squared minus 20y, then plus 100. Wow, this one has been expanded now. With this expansion, I can now equate it. I can equate such an expansion to either A or B. To either A or B, because they are also equal, so that I may get another equation. So this one can be equated to, if I equate to A, then I will say this one is equal to x squared minus 4x plus 4, then plus y squared minus 10y plus 25. So now we group like terms such that x, let me show you how things will cancel out very easily. X and x will cancel. Then y squared taken to the other side, it will cancel with y squared. Now we are having negative 8x. Then there is negative 8x plus 4x. That gives us negative 4x. Then again, I'm having a negative 20y, then plus 10y. It becomes negative 10y. Then finally, there is we can take the constants to the other side, whereby I should start with, on the other side, I'm going to have 25 plus 4, which is 29. Then I subtract 116, which is giving me negative 87. Negative 87. Those are the values. We can now solve, we can call it equation 2, sorry. Then now we solve simultaneously. And when we solve simultaneously, from equation 1, we can say x equals to, we are taking 6y to the other side, so that we have 44 minus 6y. Then we divide it through by 2. 22. We divide through by y, by 2, we shall get 22 minus 3y. So in the second equation where there is x, we substitute 22 minus 3y, then minus 10y equals to negative 87. We can now open brackets, negative 88, positive 12y, plus 10y, these are minus, sorry, minus 10y equals to negative 87. So we can talk of now 12 minus 10. 12 minus 10 should give us a 2y equals to, remember, you should be confirming some accuracies so that we may not make any mistake. This one we add 88, I'm getting exactly 1, and so the value of y is 0.5. With 0.5, the value of x can be obtained from this 22 minus 3 into 0.5, and this will give us you know that will be 1.5. So 22 minus 1.5 will become 20.5. 20.5. And that means the coordinates of the center shall be 20.5, 0.5. So that is how we operate such a question. We are almost winding up. Number 11. A bag contains 4 balls or 4 white balls and 5 red of similar shape and size. 2 balls are picked at random without replacement. Underline without replacement. Find the probability that the balls are both white. Okay, it's good for you to be guided by what we call a probability tree diagram. Though some of the question can still be done. Vivian Nyambaria, thank you so much. What if you are given only 2 points, say A and B? Okay, you can only be given points which will aid you to get to the center of the circle. Without such, you cannot get. Because alternatively, this question can also be done this way. Alternatively, let me get back because of that question. We can all agree that when we connect A to B, we shall get a chord to that circle through those points. That is a chord. And we all know that in case a chord is bisected perpendicularly, that bisector of the chord will pass through the center. All bisectors of chords pass through the center. Again, we can connect B and C. We get a chord BC. And again, we bisect perpendicularly. So any bisector of this chord will also pass through the center. And so we can say, because all the coordinates are provided, you can get equation for the chord. That means we can also get equation for the perpendicular bisector of each chord. So if we get equation of the perpendicular bisector of the first chord, equation of the perpendicular bisector of the other chord, we can use those two equations to find the point of their intersection. And where they will be intersecting will be the center of the circle, because they must both pass there. It is the only coordinate they can share. Remember, there will be something else. You'll be required now to find the midpoint of each chord for you to find the equation of such a bisector. So the question can have alternatives, but you can't be given 2 points. You must be given enough coordinates to guide you to the final answer. 11. A bag contains. So I had said in this question, some are too simple that you can just proceed. But in most of the cases, it's good for a student to be guided by what we call a probability tree diagram. For instance, we are picking twice, and we are starting with either a white or a red ball. Picking white because they are 4 and the total is 9, and picking red is 5 out of 9. Now, in the second picking, if we had picked white, picking white again, the probability, because there is no replacement, goes down to 3 out of 8. That means the probability of picking red now becomes 5 over 8. In every bracket, remember, you are supposed to get 1. The probabilities on any bracket should give us 1, because in a bracket, you display what we call mutually exclusive events, and their probabilities must add up to 1. If you had picked a red, picking red again should now go down to 4 out of 8, which means for white should be 4 out of 8. Now we have all the probabilities displayed, and we can also write the outcomes here. White, white, we have a white, red, we have a red, then white, we have a red and red. Find the probability that both balls are white. So we need probability white, white. This is going to be 4 out of 9 multiplied by 3 out of 8. So this is going to be 1, 3, 1, 2. So 1 out of 6. That is the probability that both balls are white in color. Part B, of different colors. Probability picking 2 balls of different colors. So it can be probability we pick white and red, or probability we pick red then white. Those are both cases for different colors. So we can have a white 4 out of 9, and red shall be 5/8. Or means addition in probability 5/9, that is red, then white 4 out of 8. 4 out of 8. We can just compute this. 4/9 multiplied by 5 out of 8. Then we add 5/9 multiplied by 4 out of 8. This is giving us exactly 5/9. So the probability is 5/9. Thank you so much. All right, we continue. Our number is still on the screen. Number 12, a point P, 2, -3, undergoes transformation represented by the matrix 3, 0, 0, 1. Find the coordinates of P. For us to get the coordinates, we should know that a matrix multiplied by object should give us image. The object should be written as a column vector of the coordinates. So we are starting with 3, 0, 0, 1. Then we have the object now, whereby we change it to a column vector. Now we carry out multiplication, row multiplied by column, row times column. So we start with 3/2, 0/-3. That's going to be 6. Then again, the other row here multiplied by the column. So it will be 0/2 and -1/-3. So that becomes 0 plus -3. So the coordinates of P, coordinates of the image of P, we can call it P prime, is going to be 6, -3. 6, -3. That is the coordinates. We have number 13 on binomial expansions. We are going to carry out the binomial expansions. Aha. Thank you so much. Thank you so much for following. And see, you guys are really patient. We are winding up. Remember, we are number 13 out of 16. We are finishing up. Okay. Remember to subscribe, gentlemen. Remember to subscribe. Remember to subscribe. Thank you, Mr. Motuko, for following. From Goto Boys, I notice your presence. Thank you so much. Goto Boys students are also following, and I recognize you. I've seen George, I've seen Jaden. That is a great work. Number 13, expand. For us to expand, we are supposed to first of all know what we call the binomial coefficients of the given power. The binomial coefficients. This one can be even read directly from the mathematics tables. So you don't have to cram them, you don't have to master anything, but you can just get them from the Pascal's triangle, whereby for the coordinates, for the coefficients of for the coordinates of or rather the coefficients of power 2, which is the least power that you can raise, binomial expansion 2, they are 1, 2, 1. So that's for power 2. Then for power 3, they are 1, 3, 3, and 1. For power 4, 1, 4, 6, 4, 1. For power 5, they are 1, 5, 10, 10, 5, and 1. Then for power 6 now, they start with 1, 6, 15, 20, 15 again, 6 and 1. So these are the ones that we are going to list first, the powers of 6, but we have been instructed up to the 4th term. So we start with 1, then 6, then 15, and the 4th term will have a coefficient of 20. So you list the coefficients first. Okay, I know there are those who expand, then they feed in the coefficients later, but I encourage you people to start by putting down the coefficients. Sometimes you might think you will expand, then you insert the coefficients, and little do you know that sometimes you can even forget. So it's good you list them first. Now you begin. The first term, you have 2 raised to the total power of 6, and the other term, which is x, raised to 0. And in the second term, you shall have 2 raised to, the power now goes down to 5, and x raises to 1. Then in the third term, we shall have 2, the power dropping to 4, and x, the power increasing to 2. And finally, in the fourth term, we will have 2 power 3 and x taking also power 3. Now we can finish up. 2 power 6 is equivalent to, is it 64? Yeah. 2 power 6 is 64. Then times 1. X power 0 is also 1. So we will get 64 as first term. Then we shall add, we take 2 power 5, which is 32, times 6 times x. So that 2 times 6 is giving us a 192 by 6. 192, yeah. 192. Then x plus 2 power 4, which is 16. We multiply now 16 by 15. We get 240. And now we are having x squared at that point. And finally, we add 2 power 3 is 8 multiplied by 20. This gives us 160. Then x is now power 3. This one is now expanded according to the instructions up to the 4th term. So we have expanded up to the 4th term. Maseno School, thank you so much. You don't have to master anything, the coefficients. Somebody saying you can also get them from the calculator. Well and good. There is no problem. As long as you will extract the correct coefficients, then it is well and good. As long as it will make the work easier, then well and good. Now with the expansion, we can apply it. Hence, use the expansion or the above expansion to evaluate 1.96 power 6 correct to 4 dp, 4 decimal places. So we are going to equate 2 plus x raised to 6 can be equated to 1.9 also raised to power 6. Then we shall tell ourselves that if they are equal, if the powers are equal, then it means these bases of 2 plus x are also equal to 9 to 1.96. Then now you can remain with x by taking 1.96 and you subtract 2. This will give us 1.96 and you subtract 2. You should know that you are getting negative 0.04. So now we go back to our expansion with this value now. 64 plus 192 with negative 0.04 substitute x. Then we add 240 and negative 0.04 now squared. Finally, plus 160 with a negative 0.04 we raise to power 3. Then you can key in this expansion just as it is to the calculator and you give us the value 192 into negative 0.04. Then we add 240 into negative 0.04 we square plus 160 into negative 0.04. This one raised to power 3. I'm getting exactly 56.693. Then we have 76. Because of the 4 decimal places instruction, that becomes 8. So this is exactly what I am getting. These expansions are usually very close to the exact value. In case you take 1.96 and you raise using the calculator, raised to power 6, you get a value which is very close to already what you are having here. For example, to 4 decimal places, I'm getting 56.6939. And what I have is 6938. So you can use such an accuracy to know that you are already on the right track. Number 14. Remember the day tomorrow we'll be doing a paper 1, a very good paper. Remember to be around tomorrow. Remember to come with a friend. Remember to invite people, even those who hate mathematics. Bring them around. Mumbuni School, thank you so much. I've seen them. Edna Mutinda Ukia Girls, I recognize you. Victoria Shunza. That's good. Victoria. Victoria. Moy Boys High School. Kaplamai. That's wonderful. St. Mark's High School. Cherangani. That is great. Mwalimu, is there a way unaweza pata coefficients kwa calc? Even if there is a way, they can easily be obtained from the mathematical table. Just read them out, please. Nobody will penalize you for extracting them directly from the maths table. Let's look at number 14 towards the end. Find the value of x in the equation. 10, the sine of squared x, minus 7, the cosine of x, plus 2 equals to 0 for the range between 270 and 360. So we are going to solve this equation. Remember, there is what we call trigonometric identities. And one of the basic ones says that the sine squared of any angle plus the cosine squared of the same angle should give us 1. And this means we can say that the sine squared of an angle equals to 1 minus the cosine squared of the same angle. With that arrangement now, we can apply it in the first part so that we have 10. Instead of sine squared of x, we can use 1 minus the cosine squared of x. Then minus 7, the cosine of x, plus 2 equals to 0. This means now we can have 10 minus 10 cos squared x minus 7 cos x plus 2 equals to 0. We are finishing up with this equation now. We can now group like terms together, whereby 10 and 2 becomes a 12. Yeah. Then we can also arrange such that we start on the right hand side with the 10 cosine squared of x. Then we also follow with 7 cosine of x. Then 12 is taken to the other side, minus 12 equals to 0. Now with this, we can let cosine of x to be something like t. Let cos x be t. When cos x is t, we can now say that in the first case, we'll have 10t squared plus 7t minus 12. This is equivalent to 0. If that is equivalent to 0, we can solve this equation very easily using the completing square method, the factorization method, the quadratic formula. Any can work for us. So we can say t squared plus 7 out of 10 t, and we take the constant to the other side now, 12 over 10, which will be 5. 12 over 10 by 2, 12 over 10 by 2, it will be 6 over 5. We can add a constant to both sides. Remember, we are using the completing square method. C is usually given by B out of 2, then we square. So the value of B is 7 over 10. When we divide by 2, it will be 7 over 10 times half. So 7 over 20 squared will be 49 out of 400. So we add 49 over 400 and also 49 over 400. So we can factorize the left-hand side to have t, then the sign is a positive there, plus 7 out of 20. This is equal to, when we add 6 over 5 and 49 over 400, this is giving me 1. It's giving me 1 and 129 out of 400. 1 and 129 over 400. We are finishing up. This is going to be, now we take, okay, this is squared, sorry. We just factorized. So when we take square root for both sides, it will be t plus 7 over 20 equals 2. We take square root now on the other side also, and that will be 1 and 3 out of 20. So to remain, okay, plus or minus. When we are taking square root, we usually have plus or minus. So this is equal to plus or minus this value. The value of t can be 1. When we take this value and we subtract 7 over 20, we get 4 over 5. Or we take negative 1 and 3 over 20. Then we subtract 7 out of 20. That will be negative 1.5, which is impossible. So t equals to negative 1.5. Now, when we are talking about cosines, we cannot have a value greater than 1. So we work with t equals to 4 over 5. So now we see the cosine of beta, or cosine of x, equals to 4 out of 5. If the cosine of x is 4 over 5, then now we can get x by taking the cos inverse of 4 over 5. This value is going to be shift cosine 4 over 5. This is giving us exactly 36.87. 36.87. Remember what we have been instructed, that we need such a value within the range 270 and 360. Therefore, actually that range is simply the fourth quadrant. Therefore, an angle of 36.86 in the fourth quadrant is going to be, when you measure such an angle in the fourth quadrant, it's going to be, just take 360 and you subtract what we have. 360 minus this value, I'm getting 323.13. 323.13 degrees. That is the only angle, because the range which has been provided is for such a quadrant only. So that is the angle. Number 15 on logarithms. Find the value of x. Find the value of x. Find the value of x. Is there another session tomorrow, sir? I will schedule a lesson for paper 1 mathematics, a very serious paper. We'll be discussing Mokasa. Please make sure you turn up tomorrow. Find the value of x. For us to find the value of x now, we are solving a logarithm equation. There is no base which has been provided for this logarithmic equation. Allow me to introduce base 10, whereby I shall say the log to base 10 of x minus 2, then plus the log to base 10 of x plus 1 equals to, instead of 1, remember there is a law which says that the logarithm of a base to the same the logarithm of a number to the same base, or to the base which is equal to that number, is giving us 1. So instead of 1, we can have the log of 10 to base 10 plus the logarithm to base 10 of 4. And now with this, we can apply just one law of logarithms, which says that the log of a number a to base b plus the log of a number c still to base b can be solved by taking the logarithm to base b and we take the product of a and c. That means we need to say the log to base 10 of, now we multiply x minus 2 and x plus 1. We also on the other side say the log to base 10, then we multiply 10 by 4. 10 by 4, yeah. So now we can drop logarithms and we quit these sides. When you expand the left hand side, we shall have x squared, then plus x minus 2x, so negative x minus 2 equals to 40. Equals to 40. Equals to 40. So the values of x can now be gotten when we use the completing square method. X squared minus x equals to 42 on this side. We can add a constant and also a constant to the other side. The constant will be given by negative 1 over 2 squared. Negative 1 over 2 squared will be a quarter. And we also add a quarter to this side. When we start factorizing, this is supposed to be the square root of this part, x minus is the sign which follows, half squared equals to 42 and a quarter. So with this now, we can talk about the square root of both sides, whereby we shall say x minus half equals to the square root of the other side, 42. We get 6.5. So the square root is either plus or minus. Plus or minus 6.5. To get x now, we take 6.5 plus half, giving us 7, or negative 6.5. Negative 6.5 plus half. It becomes exactly negative 6.0. So it's either 7 or negative 6. 7 or negative 6. Those are the values of x. We got a question here. Number, yeah, we are finishing up. Thank you for holding on. Thank you for holding on. Thank you for holding on. Remember to subscribe, gentlemen. Remember to be subscribed. Remember to invite a friend for tomorrow's section. It's going to be powerful. Number 16. The sum of two numbers is 9. The sum of the square of the number is 41. Find the numbers. The sum of two numbers is 9. When we take a number and we add another one, we are getting 9. That is the first instruction. The second instruction is saying the sum of the squares of the numbers is 41. When we take x squared and we add y squared, the sum of the squares is giving us 41. Find the numbers. We can use a substitution method, whereby from equation 1, we can say the value of x equals to 9 minus y. And so instead of x, we shall have 9 minus y squared, then plus y squared equals to 41. We are working out this. 81 minus, this will be 18y. Then we add y squared plus again y squared. We should get 41. At this value now, or at this point, we can have 2y squared minus 18y. It It's a quadratic equation. So we can have 81 minus 41, giving us 40, equals to 0. We can simplify this equation, whereby the value of y squared is divided by 2. We also get 9y. Then we add 20 equals to 0. Can we work with factorization this time round? It's a quadratic equation, so we need factorization. For factorization, we need a product which is equal to AC, that is 20, and a sum which is equal to B, -9. So two terms, when added, -5, but when multiplied, they give us 20. So -5 and -4. The sum is -9, the product +20. We substitute -9 with this. So y squared minus 5y minus 4y plus 20 equals to 0. We factor out y, so that we have y minus 5 plus, no, minus 4, sorry. Then we remain with y in brackets minus 5 to give us a 0. So we need to have y minus 5 as the common factor, then y minus 4 as the other factor, equals to 0, which means the values of y are either going to be 5 or y equals to 4. So the values of y are either 5 or 4. And now with the two values of y, we can get also two possible values of x. So x is going to be, when y equals to 5, the value of x shall be, we take 9 minus y. So 9 minus 5 is 4. And again, the value of y can be 4. And in such a case, the value of x is going to be 9 minus 4, 5. So the value of y can be 5 with x being 4, and the value of y can be 4, then that of x becomes 5. So that is how we handle such an equation. It's called a simultaneous quadratic equation. Thank you so much for following. Remember to use our number on the screen. Subscribe to this platform. See you tomorrow for another lesson. Good night.